Welcome to the session 2 of the lecture 13. And before going to the break, we have seen a very important formulation of the machine learning problem that given some item that has n features, how can we find out the right parameters? So we have seen that the parameters are represented by W's, and the equation is this. So one way was that you define the hypothesis with respect to the W's, and how to train the W's. We have seen that you can all the misclassified examples, when these are data points, you are updating the weights with respect to this formula, that is the multiplication of alpha, that is the learning rate, a small number, and then yi xi, what is the actual prediction they have, and what is xi, and by this I'm going to update this formula. So you see, I told you that after multiple iteration, what would happen, that your weights are actually in every step they are adjusted. After some time they would not be getting adjusted because everything become correct. So you would be finding the right weights for that. So, and whenever you have a weight, you can find out that how good I am using this particular formulation, that is called the loss, how much loss you have. In the classification, the loss is that at how many places you are differing with the actual classification thing. So this is sort of formula. And the regression, you want to be near to the value that is given to you. Therefore, you take the difference between the value that you are saying and what is the actual value. Take the square of this. The square is needed because negative becomes positive. All right, this we have seen into the earlier case, and now we are going to alpha value could be any value, sir. No, alpha should be a very small value, say 0.1, and it should be a small value, and so that in every step the things don't move very far. All right, so now we are going to change. This is the next thing that I'm going to tell you. Okay, in one class, the second thing is coming, and here what we have talked about till now, we have talked about that what is the classification. Okay, we have seen that given the item y was a classification, that what is the classification. Now I am going to change this thing. I am going to tell that don't tell me that what is the classification. Give me the probability of this classification. For all practical purposes, we can safely assume that there are only two classes, positive and negative, 0 or 1. Two classes are there, and ripe or not ripe, only two classes are there. I want to find out that can this model give me what is the probability of this item being true. So if I find out that the probability of that particular data item being true is 0.3, immediately give me that the probability of false is 0.7, because if it is not true, then it is false. Two classes only, so it is 1 minus 0.3. So can I ask you that in this scenario, when my system is not going to give me any classification, it is going to give me the probability. Now, listen my question. My question is, I have developed a system that is going to give me a probability of being positive. Okay. And let's assume that I have fed an example, and for that it has told me that the probability of being true is 0.3, probability of false is 0.7. Can you tell me what is the classification, true or false? Can you tell me it is true or false? What is the classification? Tell me. Not able to answer this? We do not have to set up a classify here. Numbers are not, probability of being false is more. All right, you can see, very good. Probability of false is more than the probability of true, and therefore if I ask you that what is the classification, you would say false. Okay, okay. Two possibilities are there now, true and false. But my system is going to give you your system is going to give you the probabilities, but after the probability you have to tell that what is the classification. And if this is the system, you can tell that the classification is false. Classification is false. Are you with me? Everybody understand this? Can anybody write yes? If you have any problem, write no. So now earlier I know somebody write no. Markande, you have a problem. Okay. All right, let me tell you once again that earlier what we wanted, that given this training data, I want to develop a function that is a hypothesis function. Given a name data item, my function was going to give me whether I should give him a loan or not loan, true or false. Okay, this was, yeah, up to this part you understand this? Is it clear? Can you write yes? Up to this part you are with me, that there are some true data is shown to the system. System had developed a model, and it has utilized that model to come up with a hypothesis function h, and using that function it can, for any given item, it can tell that whether this item is true or false. This part you understand? Or can you write yes? Hmm? I'm not getting any message from your side. Are you there? Arkande, please write yes or no. What is the problem? At least you can write no if you don't understand. No? My God, I think you have some problem. Okay, no issues. So I was telling this thing that given the training example, where there is a function, and this using this f function, this y1, y2, ym are actually created. We don't know that function. Therefore, we have come up using some jugglery. We have come up with the h, and we have seen that earlier that what is the algorithm possible. Using that thing, we have come up with the yi. Okay, all right. And our y value may not be equal to the y actual thing, but this is our hypothesis, we call it. Now I am changing this function. Instead of giving that whether it is 1 or 0, it is going to give me what is the probability of being 1. If the probability of 1 is given to me, I am going to change this function. Number 1, this particular my model is this time going to give me what is the probability. And if it gives me a probability, then I can utilize that probability to give the right answer using, but just see that which particular part it is going to say more probable. So I'm saying that it is false or otherwise true. This is part I wanted to tell you. All right. Now I want to bring you some more mathematics that is very easy. And the problem, just, can anybody write yes? We can go. Can we go ahead? Can we go ahead? Okay, all right. Okay. So now I want to find out what is the probability of observing a data set. एक नई बात है. It's very difficult thing. एक नई बात है. You have not seen that because I have shown you a data set. I have shown you a data set. Earlier, what was happening, that I had given a database. Now you have to come up with a hypothesis. I want to ask that what is the probability that you would see this database. Okay. For example, when I toss a coin, fair coin, 100 number of time, what is the probability that you are going to see all ones, all heads? बहुत कम probability है ना? What is probability that you are going to get 52 heads? काफी high probability है. So this I want to say you that assume that you are flipping a biased coin, and where the probability of head is 0.4. Okay, if I flip this 100 times, how many head is expected? 40 heads are expected. Okay, because probability of head is this. 100 times flipping would give me 40 heads. Now, what is the probability that you see this data? Head, head, tail, tail, head, head. What is the probability of getting this? Probability of head is 0.5. Probability of tail is 0.6. Okay, you know this formula. And if all the trials are independent, means every time when I'm picking it is independent of others, then the probability of data given theta, means this parameter. What is the parameter? Theta is the parameter. That probability of it is 0.5. The probability of this data is पहले head आए, then head आए, then tail आए, tail आए, tail head आए, head आए. तो इसकी क्या probability है? पहली बार head आए, अगली बार head आए. Independent, if the things are independent, the probability get multiplied. The probability of seeing this. Theta is the parameter I told you, na? Theta is the parameter. That probability of head is 0.4. All right. So head, 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 tail, tail. The probability would be multiplied because I know that these are the probabilities. You can find out for this. This is the probability 0.006216. This is the probability that you will see this database. All right. Can you find out this? So for given a parameter, you can say that. Okay. And important thing is note that the order of element in the data set do not matter in the trial because they are independent. because they are independent. So the probability of all the heads then all the tails is same. In fact, in any permutation is same. What is theta? It is a parameter. For our case, the representation of this, it is 0.4. Are you with me? Should I go ahead with the next slide? So given the parameter, you can find out what is the probability of seeing the data. You can find out. All right. So देखो कितना बढ़िया example आ गया. Now we have an example that let's assume that x is a feature that is 10, 11, 12 randomly. I just put something, and let's assume that the y is there. There is some 0, 1, 0, 1, 0, 1. How come this 0, 1? Randomly I had put something. And let's assume that you come up with some hypothesis. Hypothesis means it is a function. Given this 10, it would produce some value. And let's assume it produces 0. I am not telling that what is this function is. But can you tell me this function, h1? This h1 is given 11 produces 0, given 12 produces 0. Can you give me? And similarly, this is a different function that gives you 1, 0, 1, 0, 1, 0. Can you tell me that what is the h1? Can anybody tell what is h1? Can you tell me what this function is? That's very easy to see. Let me tell you. All right, I got the right answer. If x is greater than 13 or not, the test is x is greater than 13 or not. If it is greater than 13, it is 1, otherwise 0. So you see that there is a function. Similarly, what is s2? S2 is 0 is even number. If it is even number, then it is 1. Odd number, it is 0. Even number, 1. Odd number, it is even odd number. You see that lot of functions are possible. So these are the functions. The hypothesis is a function that aims to provide the value of y. ये हमने देख लिया that this was the data given. I have two hypotheses. Multiple hypotheses are possible. Similarly, lot of hypotheses are possible, and we have seen that these things are size of hypothesis space is at least 2 to the power m to represent everything, to represent how many hypotheses should be possible. All the possible combinations that are here you can assign. These many number of hypotheses are needed. That is going to be a very big number. That is 2 to the power m. We are not going to in much detail. So let us find out that given the data, what is the probability that this hypothesis? Somebody is asking what is y. Y is the output now. Y is the output. Given this is the output that I am targeting. So I have used various functions to target this. All right. See this equation. Bayesian learning says that when lot of functions are given to you, Bayesian learner says control A. Okay, so we are going to talk about the Bayesian learning. Okay. So we, I told you that h1, h2, h3, dot, all the different many functions are given to me, and a database is given to me. Okay. So what is the probability of this hypothesis? 0.1. What is the probability of this hypothesis? 0.2. What is the meaning of this hypothesis? This is because hypothesis represents a parameter, and given this, if this parameter is true, then what is the probability that this database would come? This you can find out. We have seen that example that given if the parameter hypothesis represents a parameter, and if this is the parameter, then what is the probability of seeing this data? This I had finding out. All right. So I want to see that what is the probability of hypothesis. What is the probability of this hypothesis given this data? So let's say it is 0.115. So which is the best hypothesis? The best hypothesis is this. This is how we can select. So if we can find out what is the probability of the hypothesis given the data, okay, then whatever hypothesis that maximizes this value, I can take that hypothesis and give it as an answer, because वही hypothesis चाहिए ना जो best है, सबसे अच्छी है, जिसकी probability ज़्यादा है, the probability who has the hypothesis who has the highest probability. I want to answer that. All right, and this thing, you know that there is a Bayes rule that says that it is probability of data given hypothesis into probability of hypothesis divided by probability of data. This is the formula, Bayes hypothesis, Bayes rule. Okay, so Bayes rule gives you this thing. Okay, all right. So let us choose, and then our target is choose that particular argmax h. Okay, argmax of h means you want to find out that hypothesis that maximizes this. So you know the argmax function. I think we have discussed this, but again, just for some completeness, let me tell you. that let's assume that you have an array where the values are 1, 19, 0, 20, 31, 15, 5 and 9. Let's assume these are the values. And what are the indexes? First index, second index, third index, fourth index, fifth number, sixth number, seventh number, eighth number. I want to find out that argument. This is the argument, the first item, second item. Okay. I want to find out argmax of if it is a I, and let's assume that these are the I means indexes, argmax of I, AI. If I want to find out, AI को maximize करता है. So can you tell me, AI is the 1, 19, 0, 20, 31, this. So what is the maximum value into this? Can you give me what is the maximum value? It is, if I have an array that has all these values, maximum value is 31. Okay, maximum value is 31. All right, maximum value is 31. And what is the index that maximizes this? What is the index that maximizes it? It is 5. Okay, so therefore argmax, this thing, if I ask max of AI, it is 31. But if I ask argmax of AI, it is 5. You understand what is the argmax of AI? That parameter which maximizes this value. Okay, all right. So our task is to find out that hypothesis which maximizes this particular value, probability of H given data. We want to find out that hypothesis, and I am going to call that hypothesis as the maximum posteriori hypothesis. Okay, so we know that this is the equation by Bayes rule, so we can put this formula. And if you want to maximize this particular thing, then you can maximize this thing only, because probability of data is not dependent on the hypothesis. So therefore, even if the hypothesis is changing, probability of data is not changing. So you remove this part. So you see that probability of data given H into probability of H. Okay, all right. So this remains. So this is if any hypothesis that maximizes this value is the map hypothesis. But sometimes what is the probability of hypothesis? The earlier who knows what is the probability of hypothesis? Sometimes it is not known to us. So therefore, if every hypothesis is equally probable, then we can say that this particular thing is not required. And when we search for those kind of hypotheses which actually maximizes the probability of D given H, then that particular hypothesis is called the maximum likelihood hypothesis or ML hypothesis, and it is argmax of H given probability D given H. Lot of mathematics, okay. So I hope you understand this. We are going to have an example, and the same example that we had. So you see that the H1 hypothesis had two places where it is going to do the error. You see that the same example that we had. These two places there is an error because it was 0 and this hypothesis is telling 1. All other places it is same. Second hypothesis, you say that here it was 0 giving 1, therefore there is an error. Multiple places there are errors. So which is but let's assume that initial hypothesis is somebody given me initial information that my bias is that H1 is good with a 2 by 50 and H2 is 6 by 50. Okay. Then since H1 and H2 are correct, what is the probability of H1 being correct? What is the probability of H1 being correct? It is 7 by 9 because at the 7 places it is right, and there are 9 examples. So can you find out this? Are you with me? What is the probability of H1 being correct? It is 7 by 9. Yes? No? Can I write yes? No? What is the probability that H1 is correct? What is the probability that H1 is correct? Can you give me? Yes, it is, because you see that how many places it is correct. 1, 2, 3, 4, 5, 6, 7 places correct. 7 divided by 9. What is the probability that H2 is correct? Can you give me? 3 by 9. Because at the 3 places it is correct, otherwise it is wrong. So you see the probability is this. So if I want to posterior, means if I multiply this thing with the known this parameter, what is the bias, whatever my bias is, if I multiply this, I get this number and this number, and you see that when you multiply, then you get 0.43 and 0.56, and therefore the bigger number is the second one. Therefore, this hypothesis is best for you. Why this function is best for me? It is bad function because I have put higher confidence on this. Sometimes I have, because I know that ये भी गलती कर रहा है मेरा बच्चा, but he is very good, at the later point I would do be better. So this is my biases. Yeah, okay. This exam is not that much important, kind of thing. So 6 by 50 is this. So if I include that part, it is this. Otherwise, if I say that no, I'm not going to consider anything from outside, whatever I'm seeing into the data that is only important, then I'm going to search for the MAP hypothesis. ML hypothesis. And what is the ML hypothesis? It is H1 because you see the probability of that particular thing. This is 7 by 9 is greater than 3 by 9. So therefore, H1 is the ML hypothesis and H2 is the MAP hypothesis because MAP hypothesis maximizes the probability of data multiplied by initial sum value that is provided to you. And ML hypothesis don't see that anything previous is there. Only I see that what is current. So on the current you see that this particular H1 is better. So therefore ML hypothesis is H1 and other is 3. So how can you go ahead finding out the H1? What is the brute force method that I told you is very difficult. And there is one more concept that is a consistent learner concept that tells that there could be more function hypothetical situation which are actually committing no errors. That is not important. So this slide is very important. So, sir, my internet got disconnected in between. I joined after 15 minutes. Sorry for the inconvenience. Oh, that's bad. Okay, no issue. Chalo. So I just told you that how to find out which is the best hypothesis. In terms of the ML, I see that this is the best hypothesis. In MAP, this is the best hypothesis. You know this? Now, I'm going to tell you the best classifier in terms of the Bayesian. That is the Bayes optimal classifier. And here, switching the question from the which is the most probable hypothesis, okay, to the earlier we had only talking that what is the probability of the hypothesis, okay. Probability of hypothesis we have find out by this that how many places it is correct. We are switching this question from what is the most probable hypothesis to what is the most probable classification of the new instance. The similar thing means you want to find out what the most probable classification. Okay. So sometimes people ask that is it possible to do better than the map? Yes. So let's assume an example where let the posterior probability of the three hypotheses H1, H2, H3 giving are means initially we had the confidence. Somebody had told me that there are three hypotheses H1, H2, H3 and I like the 0.54 probability H1, 0.3 probability H2 and 0.3 probability of H3. Are you with me? There are three hypotheses and my or understanding मेरे दिल की बात क्या कि I am going to use the H1 with the probability 0.4, 0.3 and 0.3. तो कौन सी सबसे बेस्ट एल्गोरिथम है? H1 क्योंकि उसके मेरा कॉन्फिडेंस ज़्यादा है. I have more confidence into the H1. Obviously H1 is the map hypothesis. All right. This is the best thing. So let's assume that the classification of a new instance some item is given to me is positive by H1 and negative and it is given by H2 and H3. Some item came to me. I ask from the H1 what is the classification. It says positive, but these two are telling negative. So should I take the positive or negative? Definitely I would take positive because I have more confidence. I would use only this hypothesis and therefore I would not ask from them. Generally, I would not ask from them. Therefore, they would be telling positive, and then I would telling that the item is positive. But if I consider all of them, then what is going to happen? Okay, by taking all hypotheses into account, the probability that X is positive is 0.5 and negative is 0.6 because with 0.3, 0.3 they are telling negative. So overall, I see that the most probable classification is negative and it differs from the map. Okay, so this is what the hypothesis, this is what the thing is, that if I use this kind of classification approach, that for every hypothesis space, I see that what is the probability of this particular hypothesis, means these values are given to me, and then I multiply this with the probability of the classification, means there is some classification for that thing, if I multiply that, what is the probability that this hypothesis is giving what probability to this item that it belongs to this particular category. And if I get the multiplication and find out that, give you that classification which maximizes the value, means the summation is actually here. You see the for all the hypotheses, I find out that for the negative and positive thing, I have find out the summation. And if I give this thing as an answer, this is going to be the best hypothesis, best classifier. The Bayes optimal classifier is the best hypothesis classifier. So ultimately, this is the formula. And if two classes are there, probability in the previous example we have seen the probability of, and we have seen that that comes out to be 0.4 and 0.6, and therefore the classification for the Bayes optimal classifier was negative. So that we have seen ना, ये तो हमने देख लिया था कि the classification is negative. The same thing is here. So this type of classifier is called the Bayes optimal classifier that consider every hypothesis into the space. But the problem is that and the most important thing that I told you, that no other classifier method using the same hypothesis space and the same prior knowledge can outperform this method on an average. Sometimes it can perform, but okay, somebody is telling us a bit slow. So look, these things are very see a very high level description. Okay, that I'm going to tell you. The high level description is this: that there is a Bayes optimal classifier that tells that consider all the hypotheses in the hypothesis space, and then you decide what is your probability, okay, of that particular item to be positive or negative. If you go like this, this is the important part, that this no other classifier method can be better than this hypothesis, and this is the best way to do. Nearly means on an average, this is the best way. But you know that there is a big problem. And what is the problem? Because hypothesis space may have infinite hypotheses. Then how would I find that? What is the classification? Given an item, should I go to the infinite number of hypotheses and find out what is the classification? It becomes impossible to do. बिल्ली के गली में घंटे कौन बांधेगा? It becomes infinite. Okay, space भी infinite हो गया. Best hypothesis आपने बताया, but its space becomes infinite. How can I find out the solution? Can you see this? This hypothesis का problem क्या है कि for every hypothesis you have to find out, for every hypothesis, summation term is for every hypothesis in the space. Every hypothesis space are supposed to be very large, therefore I cannot do this hypothesis. So therefore the biggest issue is this. Then gives you another method. It tells you that the best way to go ahead with this approach, that is the Gibbs algorithm. And it tells you that ऐसा करो कि it is a suboptimal method. It is not a good method. If the accuracy was अगर वहाँ पे error was 10%, so it can do 20% error, but not more than 20% error. Means the error would be upper bounded, and it is only double, upper bounded by the double. Okay. So Gibbs algorithm says that lot of algorithms are there. Pick one of them using a probability distribution. That is choose a hypothesis with a random according to the posterior probability distribution. Means whatever distribution this particular value was, probability of hypothesis space given the data, use this particular hypothesis this as a probability of selecting this particular item. And then you draw only one algorithm out of using, if you are going to follow this distribution, only pick one hypothesis from the space and वही वाला apply कर दो. Okay, Gibbs algorithm क्या कह रहा है? What Gibbs algorithm says that lot of algorithms you have, a lot of hypotheses you have, you pick only one of them. How to pick? Use the posterior probability. जो probability वहाँ पे निकाला था उससे. You pick one algorithm out of that, and you use this algorithm to find out the classification. Now it's fast because drawing is easy. एक खट से हो गया एक step में, and then you can one step you can apply and you can find out the solution. It's very fast, and the guarantee is that you would not be. It is at most twice as error it can do. It is upper bounded, but it is a suboptimal method. I don't want this. Okay. Okay. So problem क्या था? Multiplication बहुत करना पड़ता था, and therefore it's very difficult to find out. All right, another classifier that we are going to see, it is a naive-based classifier. Okay, the next method is a naive-based classifier. Bayes classifier is highly practical. Naive-based classifier is a highly practical Bayesian learning method. So this algorithm is the highly practical Bayesian learning method, and its performance is going to be near to the neural network and decision tree. And you know this, that is not a different, that you want to find out that particular thing. If you want to find out a v, what is the because what you want to find out, you want to find out what is the probability. And see, this is just a mathematical notation. Don't be afraid of this. This is a very simple formula. Okay. So if you have not understood anything, सब baggage हटा दो, नया चीज आ गया, ठीक है? I'm going to talk about the new thing, and you know this. पहली बात है कि आप जानते हो, you know this. Whatever I'm going to write, you know already. I'm just going to write it mathematically. So let's assume V means what are the classes. Classes could be 0 and 1. Okay, I'm going to tell, for simplicity, I'm going to take 0 and 1. Okay, so what is the probability of being 0 given the data items? Okay, this you know. And what is the probability that it is 1 given the data item? If it is 0.4, if it is 0.6, then what is the classification? Give me the answer. Turan batao. What is the classification? Can you tell me? 1. All right, you are with me. So and what is this? What is this? This is the data X. This is the features. First feature, second feature. Here it is written A1, A2, AN. Okay, these are the features. Given the features, you want to find out what is the probability. All right. So this is the fancy formula that tells that out of these two possibilities, which are Vj belongs to V, that is 0 and 1, that is Vj belong to V, V is 0, 1. So I am writing this Vj belong to V, and I want to find argmax. I want to find out the argmax. That particular classification I want to answer. This is the classification which has the higher probability. So this is the formula. कोई मुश्किल है नहीं. This is a very easy formula. All right. This was a very easy formula. All right. So you understood that. This is a easy formula. So we can use Bayesian theorem to rewrite this expression. So Bayes rule, you know that what is the Bayes rule. So if you want to find out this, you rewrite this equation, because Vj given this thing you want to find out. So you can write this. Bayes theorem says that you can write it probability of Vj multiplied by A1 A2 An given Vj upon A1 A2 An. Okay, and you know that this thing is not important because this is not dependent upon any Vj, then therefore you can remove this term, and overall this is what the probability is. So yeah, this is not a difficult to see. But how to find out this, again a big question, that what is given for this classification, what is the probability of A1 A2 N. So ultimately this is a problem. Okay, and now we have a problem, and the problem is this, that and you all are with me. Okay, that is very easy, that I'm going to discuss this moment, that I want to say that I have to find out this value. Okay, to find out a classification, can I find out this value? What is this? What is the probability of this part? This is the biggest part, means probability of A1 A2 dot A1 given 1. Okay, so you know that whenever this kind of probability scenarios come, it is very difficult to find out the solution, because this value you need to be supplied. Okay, this value you need to be supplied, and if you have n values, then how many values you need to be supplied? My God, because these things are coming from some range. What is this? Age. What is this? Bank balance. What is the next thing? Distance from his house to another place. What is this? So many features you have. So if this thing can take, say, k1 number of values, this takes k2 number of values, this thing kn number of values, so all these things are multiplied, means these values you have to specify. For everything you have to specify the probability. And for simplicity, if I take this k2, only 2, all these things, if I take the 2 possible values, then also it becomes 2 to the power n. Lot of values I need to specify, because finding out this probabilities becomes very difficult. Alright, naive-Bayes classifier says that it has an assumption that if I specify that what is the output, means output could be Vj could be 0 and 1, okay, 0 and 1. If I specify that Vj is 1 or Vj is 0, my assumption is this. Understand this particular part. My assumption is this. ऐसा होगा जरूरी नहीं, but my assumption is this particular classifier has an assumption that if you specify this thing as 0 or 1, if you specify this thing Vj, then these values are actually independent. This is what the assumption is. Generally, it doesn't happen like that. So, but naive-Bayes classifier has the assumption that the attribute values are conditionally independent given the target value. It means that if I specify that here it is 1, then these values are independent. What does it mean? If the values are independent, I want to find out their and probability. What does it mean? It means that probability of A1, A2, A3 dot 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 An given 1 is equal to probability of A1 given 1, probability of A2 given 1, dot 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 An given n. Oh, it is a very interesting thing. Means if I want to find out this probability, I have to only take how many values? N values. Okay, as opposed to 2 to the power n values. Now I need not to have the n values. Only n values would suffice. Means I can solve this particular problem. Earlier it was difficult, but now this is better way. Okay, if you have this assumption, so with this assumption with this assumption you can solve it easily. So it means that if this assumption is true, then to find out this value you can find out the multiplication only. Okay, so naive-Bayes classifier is the one which find out this particular value, probability of this and this particular thing. Lot of mathematics. Let me go into the example. Okay, then you would be very happy to with me. Everybody with me? Say yes. I'm going to have an example. All of you with me? All right. See this example. Let I give you this data. How many data item? 14 data item I give you. Say that outlook is sunny, overcast, rainy, overcast, sunny, kind of this. Temperature is hot, mild, cold, hot, mild, cold. Humidity is high, normal, high, normal. Wind is weak, strong, kind of this. Then whether I'm going to play the tennis or not, I'm going to play the badminton or not, it is written no, no, yes, no, yes, no. And this is what the final classification is. My point is, given something, I want to tell that what is the classification. This is my point is, determine the classification for rainy, hot, high, strong. Now the question is, given this data, you train a model, naive-Bayes classifier, I am specifying, and tell me what is the classification for this item. Everybody understand this question or not? Should I go ahead? No? Yes? I go ahead? So, all right, this is the question. This is the data given to me, and for this thing, I'm being asked that what is the classification. All right, you divide these things into 2 parts. Why? Because when you take the things no and take the thing positive, then they are independent. Otherwise, I was thinking that I don't know that whether they are dependent or not. Now I think that when I divided this into with respect to no and s, then they are independent. This is my assumption is okay. All right. What is the probability of yes? Given this data, what is the probability of yes? How many examples we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 examples we have. Out of them, 14 examples we have. Out of them, 9 are yes. So therefore, probability of yes is 9 by 14. Given the data, you can find out this. Is it true? Tell me. Right? Right? Yes. No. All right. What is the probability of no? Can anybody tell? Or, well, let me go back. What is the probability of no? Can anybody tell? 5 by 14. All right, because 5 no are there, and there are 14 examples. 5 by no, 5 by 14. All right. If you take the outlook, okay, and outlook is equal to sunny. What is the probability that it is yes? Okay, with yes, what is the probability that it is sunny? So you see, go into the sunny and see how many times sunny is there. Sunny is 1 here, 2 here, 2 times sunny is coming, and how many things are there? 9. 2 by 9. Can you see this 2 by 9? Outlook is no. Into the no area, what is the probability that outlook is sunny? Into the no area, what is the probability that it is sunny? No area. This is the no area. What is the probability that the outlook is sunny? 1, 2, 3, 3. What is it? What is the probability? 3 by 5. All right, 3 by 5. What is the probability? It is overcast. Given yes. Yes, overcast. Okay, overcast 1, 2, 3, 4. 4 places. 4 by 9. What is the probability? No overcast. In the no, what is the probability that it is overcast? Tell me. In the no, 0. All right, 0. And what other values are possible? Rainy. Rainy, yes. What is the probability? 3 by 9. Rainy, no. What is the probability? 2 by 5. So everybody can find out this. That's very easy. When we have divided data into two parts, then for every attribute, we have seen that what is the probability of that attribute is going to take this particular value. All right. So we have solved this, that we have seen that probability of yes is 9 by 14, probability of no is 5 by 14, probability outlook, we have created this table. For humidity, similarly, we can find out the table, for wind also, for temperature also. So we can find out this table. You are with me? Huh? Because you have computed this value. I have full faith on you. You by yourself compute and see. There could be some error. Just let me know so that I can correct it to the next slide. All right. I want to find out the probability of this particular thing. All right. So probability, what is the probability of yes? I want to find out what is the probability of yes and probability of no, and whichever is the maximum, I would take that value. What is the probability of yes? This is the equation. The probability x given s and the probability of s. What is x? X is rainy, hot, high, strong. Rainy given s, hot given s, high given s, strong given s, and probability of yes. This I want to find out. And if you go and see the previous table, yes given rainy was 3 by 9. Just see, yes given rainy. Okay, rainy, where is rainy? Okay, rainy given as 3 by 9. This was the value. Okay, so this value is here. Okay, this value at this place is 3 by 9. Similarly, you see all these values by yourself. You can verify. If you find out this is the value that we get. What is the probability of no? Again, probability x given no, and the probability of no. You see that this is the formulation, and if you find out all these values, you see that 0.274. And now tell me, what is the classification for this item? Yes or no? No. All right, because this is the high probability. Yes, very good. I'm very happy that you all have solved this particular thing. So this is how the neighbor classifier works, and you have done a very fantastic job to tell me that it can be done. And next topic that I want to pick up is actually, let me tell you that that is this particular topic, and that is very important topic, the belief networks. Okay, Bayesian belief network, and that is very important topic. But to go that, a lot of mathematics comes into the in between. So today I would cover those mathematical part, and into the next class we would be seeing that. Actually, I think Bayesian belief network going to that thing is difficult, but let us see that how we can go. Okay, so this is we have done that, how to, what is the naive Bayes classifier and how we can find out the classification given a particular table. All right, let's see next example. You know that given the probability of x, y is a probability of x, probability of y given x. This is the standard formula. Independence, if the two things are independent, probability of y and x are independent, then it means that probability independent means what? Given x तो कोई फर्क नहीं पड़ेगा. Okay, probability of y given x is probability of y because x it is independent of x. तो होने नहीं होने से कोई फर्क नहीं पड़ता. तो can you give me when two things are independent? When I am tossing two coin ना, तो first coin दूसरे से independent है. पहली बार क्या आया तो उसे कोई फर्क नहीं पड़ता. It is not going to affect any way that what is the next time going to come. So those two events are independent. So if I see that first event is the draw into on the first draw, if y is the draw, the second draw, if I want to find out the probability on the second draw, probability of y would be maybe 1 head or tail something. It's not going to depend upon this. Somebody is asking the question, what is the meaning of probability of x comma y? It is x and y, means you want to see both the things should happen. Probability of x and y, it is the probability of x multiplied by probability of y, you know, when they are independent. Okay, all right, when they are independent, then this is the case. You know the Bayes rule that we have discussed earlier also, this is the Bayes rule. Then a very important concept is the marginalization, and this is actually Can you see this? This is a very small mathematical concept that tells that if probability of x and y is given to you and you find out the summation across all the y's, then you get the probability of x. Means if you want to remove this y, probability of x and y is given to you, you want to remove y, so you sum up across all the values of y and then you are done. Alright, called the marginalization, and which actually says that if you want to find out the probability of this item where 1 to I minus 1, then I plus 1 to n, means n variables you have, but here in this n minus 1 are there because I is missing. So what you should do, for ith item you find out for all the possible values of I, you find out for 1 to n, means include the I and find out what is the value, and then you can find out the summation and then you can remove this particular item. That is from the mathematics. Sometimes there is a conditional independence that was we have used in the previous example that tells that x and y are not independent. But if I say that given this particular condition, there is some external condition set, sometimes it is possible that you say that it is independent. So that is not a big thing. It means that you are into subdomain where the things are independent. If you provide a given x, if given z, x and y are independent, then you can write that probability of x given z, probability of y given z. All right. So now we have an example for you that where it is a XOR, means there is, but this is a faulty XOR circuit, and we are going to XOR. You know, na? XOR, what is XOR? You know. XOR, what is XOR? XOR is an operation, means if x and y is given to me, u and x XOR y, you can find out. If it is a 0 0, it is 0, 0 1, it is 1, 1 0, it is 1, 1 1, it is 0. This is what the XOR operation is. Okay, but it is a faulty thing. So therefore, if you execute this circuit say 100 times, so you say that there is some time errors. The probability of this thing being, if I say the probability of being 1, probability of, because probability, what is the probability of being 1 is, it should be very less because it is 0. Probability of being 1 is 0.1. What is the probability of being 1? 0.99, because most of the time it is going to give right answer 80. Probability of C is equal to 1 given a and x and y. This is what I am going to talk, this thing. Okay, so it should be 0. Therefore, what is the probability of 1? Should be very less, 0.25. You see that these are the probability. Okay, this probability is shown over here. So why this is a probability? Because there is some error. So this is, let's you have a faulty one. The probability of A is equal to 1 is 0.65. Probability of B is equal to 0.77. So determine the probability of A is equal to 1 given C is equal to 0. So you know that probability of A is equal to 1, C is equal to 0. This probability you can find out for reverse of the marginalization. You see that if you want to find out this thing, you can include new variable B over here. And for all values of the B, and what is the probability of this? You see this, that you can write out this formula, that probability of A is equal to 1. Okay. Then you can write this, that the probability of C is equal to 0, A is equal to 1, B, probability of A is equal to 1, and probability of B. Okay. And you see that all the possible values of B could be 0, and when you put the B is equal to 0, okay. So how come I can write like this? Okay, how can I can write like this? You must have a question like this. Okay. All right. So base rule control delete. Okay. Base rule you know, and the base rule says that probability of, just see this rule. This is the base rule. Probability of x given y is y given x into probability of x. Okay. So here you see the probability of y given let me write probability of x given y is equal to probability of y given x into probability of y into Probability of x upon probability. Okay. Probability of x upon probability of y. This is the formula, you know. Okay. By the Bayes rule, you know. So you can apply the Bayes rule over here, because probability of C given 0, probability A is equal to 1. This is the what you is given to you. C given 0 is equal to what the probability of C given 0. So these probabilities you know, na? So you say that it is okay. So all right. So where we were. So this, if you apply the Bayes rule, you are going to get this particular formulation, and then here for all possible values of b can be 0. When you put 0 over here, the b is equal to 0, b is equal to 0, and then when b is equal to 1, you put b is equal to 1 and b is equal to 1 over here, and then it comes out to be these values are you can take from the table. Probability of c is equal to
बाकीचं सांगितलं जरूर आहे ते कोणत्यातरी एलएससीपीचे हेड होते त्यांनी हा दिला होता या अगदी डिटेल मध्ये एमएससीपीचे हेड श्री हे असं या साली दिला आहे असं म्हणणं दिस वॉज अ प्रोजेक्ट ग्रांटेड बाय एमएससीबी to our college to our college and it got our group got its responsibility. Basically, we developed a prototype of this whole event.
video आ रहा है क्या? हाँ? Why there is no video? आ गया शायद आ गया. Okay. Voice is there? Mandar, somebody else is there. Are you getting my voice? There was some problem. I don't know what happened. So let us not go into that detail. But I was just wanted to tell you that you can find out this value. Okay. So similarly you find out that what is the probability A is equal to 0, C is equal to 0, and then this value is there, then similarly you can find out the value comes out to be this. So you can see that sometime this is the use of marginalization to find out the probabilities. Let us also see this thing, that this is an important probability, that if you want a probability of J given R and there is some function of R and you sum up all the summation of J, then it is a function of R only, because for all the values of J you have find out the summation. So this is a small proof that you can also see from the slides. Then we are here to talk about the belief networks. So I have less time this time, but I'm just going to give you the overview, and in the next class also we are going to see the belief networks. All right. So belief network is a way to represent the probabilistic things, because you know that if you want to find out the probability of x1, x2, x100, so 2 to the power 100 different values you need to specify. That is going to be very difficult. Okay, as I told you that, because if I want to find out what the probability of this thing, for all these values, those many values need to be specified. That is going to be overkill. So what is the better way? That if somehow we know that there is independence between some of the data items, then we can directly find out the multiplication. But how do we know that what are the things that are independent? That is a big problem. Means what are the things are dependent and what are the things are independent. If we can represent them in some way, then it would be very easy to find out the multiplication. So this is the overall idea. So can you understand this part? Only simple one line. I think if you understand, then I am done. Okay, I think what is happening over here? Okay. Don't know what is happening. Okay, all right. So I wanted to tell you only one thing, and that is That is this, that if you want to find out the probability of say many variables x1, x2, x10, then how many values you need to specify. For all the possible values of x, for all the values of x2, then you find out the multiplication. Those many number of probabilities you have to specify. Specifying those many number of probabilities could be overkill because these numbers could be very large. So in case, point should be noted that in case we know that what is the dependence between the variables, then it would be easy to find out this computation. Okay, it would be easy to find out this probability if we know that what is the dependence between the variables. So how to express this dependence if we know something? Okay, chalo pata hai ki these variables dependent on this thing. How can we express? So belief networks are going to give you that way. They are a kind of network that are going to tell you that which things are dependent on what. All right, they are graphical representation. And actually, we will be taking this example very soon. And before taking this example, I would come back once again. Let me go to this particular example. This, for example, this is a one way that specifies that R is dependent, J is dependent on R, T is dependent on R and S, and R and S are actually independent. So this is given this graph, you find out this thing. And what is the importance of this? That the importance of this, that if this kind of thing is given to you, this graph is given to you, and if I ask that what is the probability of ABC, you directly write the probability of C given AB, probability of A, and probability of B. This is how you can write. How can you write? Because you see that probability of C given AB, and this is what the first term, then the probability of A, then probability of A given B, and probability of B. A given B, you see that A given B, they are independent. Therefore, A given B becomes A, and therefore you see that this formulation comes. So, however, this belief network, given this belief network, you can write out the equation by just writing this thing, that for every item, for A, B, C, because three things are there. For A, you write what are the parents. So you see that for C, what are the parent? A and B. So C given AB. For A, no parent, to probability of A. For B, it is probability of B. So can you give me that similar kind of expression for here? I think if you do this, then I would be very happy if you can write expression for this. And you just see this part, only be with me with this thing, that I say that if I want to find out probability of this, just let me write over here so that it becomes easy for you. I know that all of you can do this. That is not going to be very difficult. My students are very smart. I am very happy with that. Okay, all right. So can you, my question is that here you see this thing, okay, here, okay, 1 minute, control that. Here you see this, that this thing you see, okay, this thing you see, that if I want to find out probability of A, B, comma C, A, comma B, comma C, where A, B and C are here, so you see that it is multiplication of probability of A into multiplication of probability of B into multiplication of probability of C. Every item after given the things, you write A and B, A and B. With the A, you need not to write anything because no one is their parent. The equation is this, that for every item you are writing this item given the what is the parent of this. So here 4 variables are there. So I want to find out what is the probability of x1, x2, x3, x4. Okay, this is how I want to find out what the probability. But seeing this thing, you can say that it is, you can start from anything. Probability of x1 given what? X1 is dependent of x3 and x4. x3 comma x4. Can you write? Can you understand this part? Then I'm very happy if you can understand this part. x1 given x3 and x4. Yes, all right, very happy. Then x2 given, probability of x2 given what? Just give me. No, अभी गलती कर दिया, मैंने भी गलती कर दिया. I was also into the hurry. I have also done the mistake. Okay, let me just थोड़ा सा सही करते हैं. गड़बड़ कर दिया. I have done the mistake. What is the mistake? And hope you have understood this. X1 is x3 and x4 नहीं, x2 भी तो है. x2 is also there. Okay, all right. गड़बड़ी था. This was the mistake. And it should be x2, x3 and x4 because actually, how can you forget this? Similarly, if you multiply probability of x2 given what? 3 and 4. x3 and x4. Very good. And then multiplied by probability of x3 given x4 and into probability of x4. Okay. Now you are with me, and I'm very happy with that. That you understand that given this belief network, what is this? Given this belief network, you can find out the probability of all these terms using this formulation, and this formulation you can create using this. If you can do that, I am done. This is what a very important part, and I was not thinking that till this point we can reach, but let me go back and let me stop at this moment. I think we are out of the time at this moment. I'm going to stop at this moment, and in the next class, I think if you are with me, then we can very easily conclude this particular topic within next 5-10 minutes. Okay. All right. Thank you very much for being with me. All the slides are with you. You please go through these slides so that you can ask the question into the next class. Thank you.